December, in the 2020 December, in Sharjah area. So in the library, we have a specialized space where people of all ages can come in and innovate or create their ideas using different digital fabrication machines. So we not only have 3D printers, we also have other digital fabrication machines such as laser cutter, vinyl cutter, CNC milling machines, and even electronics inventory and robotics related kits, as well as test equipments for creating your own electronic circuits. So it's a standard digital fabrication lab. And the lab is named after Ismail al-Jasri, the father of robotics and an Islamic polymath. So welcome you all from Al-Jasri lab, and let me just share my screen. Okay, I think we can all see the screen as well, right? So the main topic of the webinar itself is where technologies meet opportunities, and my take on it as a woman in 3D printing, and specifically more openly as a woman in digital fabrication. And me myself, I just want to talk a bit about me before coming into the talks about technologies and the allied opportunities within it. So I'm an electrical engineer, and I found my passion in making and learning new technologies, and took a digital fabrication based diploma through Fab Academy, which is delivered or given through Fab Foundation. So it was a learning opportunity for me to, even though I was an electrical engineer, to be frank, after my 4-year course, I was still exploring different paths and what exactly should I take it. So that's when I accidentally came into the whole maker environment and how we can use digital fabrication and technologies such as 3D printing and develop prototypes using it. Okay. I have a question here. Yeah. Okay. So I hope for everybody, the audio is audible. Okay. That's great. Okay. So I started my career in digital fabrication in India. So India, we have innovation labs funded by government, and there were all these facilities which were open to public, and we were able to use that and start with the digital fabrication journey. And moving back to UAE was another great stride for me in terms of career, because I could get into touch with the different career opportunities and the firms that basically supply these digital fabrication tools and set up different tools, etc. So during the before the opening of House of Wisdom, I was incubated into the project, and it is a really honor to share the knowledge of digital fabrication to the people around through the learning pathways designed, and also by opening up the space for different people to use and create their ideas out. So that's a bit about me, and I would just like to talk a bit about the brief things what I would be covering. And in case you have any questions, or if you would like to make it more interactive, definitely I'm all up for it. So I would be covering basically 3 things. So first being the technology around us and how it has been progressing on a daily basis, and then how we can assess them, because as the technology is rapidly moving out, how do we access these different technologies and create your product prototypes, things like that, and how do we create the opportunities utilizing these different technologies. And coming back to, we all live in a tech savvy world, and yes, we are all users of this technology. Like, let's say the home appliances back at our home, or mobile phones which have AI in it, but we never think about how we can develop these kind of technologies. So there is the huge skill gap which we need to address. And me as an educator and a person in tech, tech and digital fabrication, my main agenda has been how we can start from early ages on, like how can we transfer the new skills or the skills of the 21st century to the younger generation. Is there any questions? Okay. Mr. Piyush, I would ask you to mute everybody else if it's possible. Okay, thank you. All right, so coming back, so skill gap and the whole, our world is basically always changing, and the technologies around us are also changing. In fact, the 3D printing itself, it's not more than a couple of decades older, and the way we see the technology being rapidly and exponentially increasing, we have lesser and lesser time to catch up. So this is where we need to address this early on through providing sessions or learning as a lifelong learners. We have to become more lifelong learners, things like that, so that we can cope up with the tech savvy world. And yes, we are all consumers of technology, but how many of us do make these? So it's a bunch of people, and that's where the whole the skill gap comes in. So addressing this and moving with the world that is fastly moving would be one of the best things what we could do, so that we could find the new opportunities. And 3D printing, yes, 3D printing is definitely one of the fastest emerging technologies. So we can say in early 1980s it began its the whole ideation and the processes, things like that. But as more and more 3D printers were available commercially to use, the technology has been also rapidly being taken up by the public. And we have different types of 3D printers in the market. Some are industry grade, some are different technologies, but the most accessible 3D printers, or one of the most commercially marketed 3D printers, are the FDM printers. And we can see like even the young generation, they are also being taught using the how to design for FDM printers itself. So as we are moving forward, even the 3D printing new technologies within the 3D printing itself would be more and more available in the market as well. So ultimately, one of the best things you could basically do is, yes, the technology or the equipment or your 3D printer changes, but or with the new year, like previously or a few decades before, whatever 3D printer we could afford, maybe it was not big enough, but currently we have even concrete 3D printers available, even that uses the same technology, the FDM. So knowing how to design and then learning about the machine is what matters, because machines can come and go depending on the current technology, and how to access them. So accessing is another issue where good thing that now the new with the new curriculums and the new outreaches for inculcating the innovation and creativity and all, we have all these STEM labs and maker labs, things like that, already open and accessible for the community. So even maybe if you are lucky enough, or if your child is lucky enough, yes, they would be having in STEM labs in the schools and in the universities and all. And with the onset of the maker spaces or fab labs, so I don't know if you have heard about these two technique terms. So fab lab is the fabrication labs, and maker spaces, again, it's a space where people basically come together, and there are a bunch of machines or a bunch of techniques or consumables being put forth, and you can actually build your ideas or try to build a small prototype for your idea. So that's the whole philosophy behind the fab labs and maker spaces. And there is like talking about fab labs, there is 2000 plus fab labs around the globe, and each fab lab is trying to meet the standards, which is like having a 3D printer or a vinyl cutter or a CNC milling machine, a woodworking machine. So you have these kind of different digital fabrication tools and techniques which is being standard available around the globe to these different fab labs. And accessing them, you don't need to be a student, you as long as like you don't need to be enrolled to a university or a school. Any person from the public can access these labs. So like I said, maybe affording a 3D printer is not easy shot for you, but maybe you can find a 3D printer within near to a fab lab, or near to your location, a fab lab, in a fab lab. So these are the points where you could afford, or you could find these machines out. And the labs or these spaces usually have some kind of training programs where you could learn how to develop your idea using the designing technology or the design thinking ideology, and build out your ideas. And yes, we cannot forget about the print hubs. So print hubs, as in some of the print hubs, like different print hubs have different capabilities. There are some print hubs that could definitely hold in and provide services such as metal 3D printing, or resin 3D printing, or printing in different sizes. And these services might not be available for in a standard fab lab, but you could basically pay and use the print hubs as well to access these technologies and build your ideas. And yes, we have, like, with the technology advancing more and more, the 3D printers and the other machines are becoming more and more commercialized and given or transferred to the market, so that everybody can use. Like I have used one of the 3D printers. It's called Toy Box. It's a small printer. It's literally enough for you to make a 10 centimeter length, width, and height model. So it's a small 3D printer with which you could maybe make a toy for your kid. So things like that. So there are even similarly small laser machines, vinyl cutters. All these different machines come in all different sizes, and if you can afford them out, definitely these options are available as well. But in case you want to experience these new technologies, and maybe you don't want to buy but you want to prototype, so in that case the best access way would be through fab labs or maker spaces, or even there are STEM labs which is under universities, which is open to the public as well. So it's depending on your location, wherever you are, you would definitely be able to find through the website fablabs.io, which has a location map. Similarly, Makerspace also has a location map mapped out, and you can check it out in the online internet platforms as well. So creating opportunities, that would be something like you can, maybe how to use a machine. Yes.
No, you go call him now. Call when you reach now. Go decide.
I don't understand when you reach. I will call it because of you. Yes.
With a question. Okay, so I would like to continue out then. Okay, so creating opportunities. So good thing you have access to a 3D printer. Good thing you have access to digital fabrication machines. What would you create with it? And how would you make, or how would you create an opportunity with it? So that is basically your creativity, I would say, and how well you know how to design or how to make your idea into a reality. So one of the best way to use the fab labs or the makerspace would be to create a rapid prototype of your idea, which you could basically use for, let's say, ideation during a pitching, or maybe to showcase the prototype to a prospect client, things like that. So digital fabrication, basically any manufacturing process that can be controlled by computer. So that includes also, yes, additive manufacturing process like 3D printing, subtractive manufacturing processes like milling, or carving techniques like that, and then robotic manipulation of any kind. So these are basically the emerging technologies. And even, let's say, the woodworking, it's also the young generation is changing, and they are using CNC milling to create computerized model of your futuristic furniture designs, and then they manufacture it, like, let's say, a small prototype, or a one prototype item, and then okay, if everything is all good, then you do it, send it for a mass manufacturing. So creating opportunities basically, if you can, if I'm pretty sure everyone in our life, everyone has problems. So if you can identify your problems and empathize with it, and then ideate for that problem, then you can basically create an opportunity with it. So if you have a problem, and if you can design a solution for it, then if it has a hardware part, you can use a rapid prototyping technology, uh, or using a 3D printer or a CNC mill for subtracting manufacturing, and create a small prototype of it. And if it is, let's say, if it's software related, ideation, so that follows a different, designing process itself. But ultimately, if you are able to provide, create your ideas out, you can create opportunities out of it as well. So for me, it was, I would love to, share this knowledge, like how can people create their ideas. So personally have supported many prototyping ideation levels of projects, and it has been an eye-opener, because the small machines can create a lot more, and they can definitely mock up and create ideas into a prototype as well. So this is my take on creating opportunities. And if you have any questions, you can definitely shoot out. Thank you very much, and you can definitely reach me out through the link, or
yeah,
through.
thank you very much, Nisha. Thank you very much. It was really a very nice presentation in which you present how the technologies could meet opportunities and how the people are working on the things. If anybody would like to have the question with Nisha, they can ask directly, or they can put in the chat. I think there is no question for Nisha. Nisha, what you can do, you can have your email. It was a really pleasure to learn from you. Now I would like to invite Miss Samia. Are you there? Hello, Miss Samia, are you there?
Is it possible to hear me now? Can you hear me now? 1 second. Hello. Hello.
Yes,
Hello,
hi.
Samia.
You can
We
open
can
the
hear you.
mic.
Hello.
Yes, yes, we can hear you. You can start your screen. You can open your camera.
Okay, sure. So first of all, good evening. Sorry for this technical issue.
Course, yeah.
Okay, let me share my screen. Just 1 second.
Yes, Samia, if you are having any network issue, we can move on to the next speaker and you can speak later on.
Okay, sure.
If this could be okay. And in the meantime, you can manage it all. I would like to, yes. I would like to thanks again Miss Nisha Elsa Johnson for her great presentation and talk on this. And I would like to thank my team as well for the AdditiveMEA for organizing this. So thank you, Mr. Naveed, Mr. Prabhat, Mr. and Miss Andriula, Mr. Ibrahim, Mr. Atta, You all have been made this possible. Without you, we cannot organize this. So, Mrs. Shilpi Sen, are you there?
Yes, I am there. Piyush, I am not Mrs. I'm Miss.
Hi. So
Hi.
Ms. Shilpi Sen is the CEO of Presta 3D. She has been working very greatly in the women in 3D printing itself. So I would like Ms. Shilpi to start her talk, and we can.
Hi, everybody. My name is Shilpi Sen. I am the co-founder and CEO of Prayasta 3D Inventions Private Limited. I will begin with my presentation. Let me know if everybody can see it.
Yes, we can.
Okay, I don't know, somehow I'm not able to make it full screen. Anyway, so I'll begin with my presentation. So as I mentioned that I am the CEO and the co-founder of Prayasta 3D Inventions Private Limited. Prayasta, as the name suggests, it means somebody who's striving for excellence, or the name suggests we endeavor in making a difference in the lives of people, especially women, with technology, with material, and with 3D printing. So I would like you to take a look at this picture for a couple of seconds and let me know what is the thought that comes in your mind.
The lady who has breast cancer, right?
Exactly. Thank you for telling me that. So basically, this is a picture of a lady who has, or whose breast was removed surgically because of breast cancer. And yes, it is true. She is a breast cancer survivor, but does someone really care about how she feels emotionally and psychologically about her body image? I would say not many, because it's very obvious. We feel, why should somebody care about a body image, whereas the person who's a survivor should be happy and thank God that she has survived. But it's not true exactly, you know. We forget that there is a need for her to look accepted and look normal. So this is the life cycle of a breast cancer. The woman, if you see the circle on the right, on the left, you will see the first image, which says that it's a healthy state of a woman. Obviously, she has a natural body, she's confident. She is diagnosed with breast cancer. She feels very dejected, depressed, and of course, she's very worried and scared. Then what happens is that she goes for a treatment, which is the primary treatment, of course, wherein she realizes that the breast has to be removed, either partially, unilaterally, or bilaterally, which is called mastectomy. And after mastectomy, what really happens is that she loses the image, or the body image. She lacks confidence in her. There's a lot of anxiety and social concern. And we lie at the last pie of the circle, wherein where we are trying to make breast restoration for women, which is basically a personalized implants and personalized prosthesis. So if you see that India is #1 in terms of breast cancer, we are the third largest incidence of breast cancer reported annually in India. There are about 4 lakh women in India who suffer from, or who has breast restoration or reconstruction. The average age of a woman is 10 years younger than the world's average, and around 13% rise is there in breast cancer by 2025. So, the idea of giving her something which is more personalized is why. First, let me tell you the difference between implant and prosthesis. On your left, you will see an implant, which is a class 3 device, and it is surgically fitted inside the body of a woman after a mastectomy that she has gone through. On your right, if you see, it's a prosthesis, which is a wearable device. You insert it, within your brazier. These are not our product. This is, we just took the pictures from the internet to make you understand the difference between the two. So also, if you see the current prostheses and the implants that are available in the market, they come with a standard shape and size. But on this screen, what I'm just trying to show you is the problems with the current implant. The current implant are filled with silicone or saline. In case if it is a saline, if it ruptures, then it is fine. But if it is a silicone gel inside and it ruptures, then it becomes fatal to the health of the woman, and she has to be immediately operated one more time. Of course, if you see the larger image, it is unilateral mastectomy that has happened to her. And if you see the image, which is saying that it is a flipped implant, meaning that the current implant has the potential of either flipping or rotating inside your body, which of course deforms the structure or the image of the chest one more time. Not only one should have a breast cancer so the implant can be done. There are at times that you're born with breast asymmetry, or because of some reason there is a breast asymmetry inside your body. That's when implants are implanted on your body for symmetry. And at the same time, which I found it very, very taxing as a woman, I was told by one of the leading oncosurgeons in India that normally what happens when an implant is ordered by the surgeon for the surgery, many a times it happens when during the surgery, when the implant box is open, they realize that the implant size is not the correct size that they had asked for. So what happens is that the surgery is not stopped. So the implant is implanted on the woman's body. At the same time, if she has a healthy breast, then it is cut and sutured to match the implant side of the chest, which is a very big problem right now. Therefore, our solution is that we believe in three things: developing the technology of elastomer additive manufacturing. We have developed a implant grade silicon 3D printer from the scratch in-house. Then of course, our technology helps us in designing very unique architecture for the implant, though, and at the same time, we require the silicon material, which is an implant grade material. We have not worked on the implant grade material at all. We are using the already available implant grade material. We did not want to get into the material side. So I would like to say here that we are the next generation of implant, and also bring your attention to the fact that for almost 30 years, there hasn't been any kind of an upgradation on how an implant is manufactured, especially breast implant. So our USPs would be a rupture resistant, since it's a 3D printed. It doesn't have any kind of a silicone gel or a saline fill. Therefore, it makes it rupture resistant. Even if a woman falls on her chest, nothing will really leak out of the implant for her to be fatal. It is suturable, and we will match the weight of the implant with the healthy side of the implant. We are going to give a natural touch and feel to the implant, which eventually will help in symmetric appearance of that lady. These are the prototype of our breast implants on the left and breast prosthesis on your right. This was developed, or the prototype is made in-house again at Prayasta. Now coming to the technology, which I have already mentioned, that the machine is developed in-house by us. We have patented the technology as well as the internal architecture of the implant, which we call it novel internal architecture. And going forward, as I already mentioned, that our machine is capable of printing the most, the highest purity level of silicon, which is the implant grade. We can also go ahead and print the lower qualities of silicon, but the machine is capable of the highest purity. That is actually the capability of Prayasta. And for prosthesis, it's a USP class 6 that is used for breast prosthesis, which again is 3D printed in our lab. Just to show you the opportunity that this particular implant grade 3D printer or breast prosthesis personalized ones have, that it is not only used in reconstruction of the ladies who have lost their breast because of mastectomy. They can also be used for augmentation, which is a cosmetic surgery where somebody is not very happy with the way she looks. And just to let you know that the market of breast implant and prosthesis is almost 2.8 billion. But here I would like to bring your attention that so far nowhere in the world 3D printing breast implant or breast prosthesis has been done. So the data that you see is a little dated data. What we are expecting is that once the personalized product, like how dental and metal implants have exponentially grown, likewise we will also see an exponential growth once we are in the market or commercializing our prosthesis and implant. So how do we do that? We go ahead and scan a lady with a handheld scanner, for which we have trained a few ladies working for us. Then this particular data is transferred to the design team in-house that incorporates our patented internal architecture. Then it is printed in our lab, which we would like to call it state-of-the-art lab, and delivered to the lady in terms of prosthesis. However, in terms of an implant, it is not a customer directly who can purchase it, but it is a clinician on a hospital that becomes our customer, and to whom we give for the further operation. This is our team. Of course, I have told you about myself. Though my expertise lies in communication, and I was working for the government of Netherlands before I started off with Prayasta. Vikas is the co-founder and CTO. He's a material scientist, as well as he is an expert in 3D printing. He was working with a already established startup in Bangalore when I met him through common friends, and we shook hands to open up Prayasta, because we realized that 3D printing can really help and bridge a gap where personalization or customization was missing. And that is the area where 3D printing, and we wanted to utilize Vikas's expertise of material, and that we realized, or we zeroed down an area, and we realized that breast restoration space is one thing where women do not have a choice. And hence we thought that we should give these ladies who already suffered from cancer, is a survivor, an identity or a body image through which they are confident. So our motto would be shaping lives better, and at the same time giving her, or rather from her to her. It is not something which is made in bulk like how the conventional implants and prostheses are. We of course have Dr. Thumsi as an advisor, clinical advisor. We have Aditya, Sunil, and Rakesh working on the technical side, electronics, as well as designing the implants and the printers. We have Ganesh and Umesh who helps us with silicon. So this is the current progress of our company. We got incorporated in 2017. In 2018, preliminary work had already started. We had filed our first patent. Then in 2019 to 20, POC was done, and with some preliminary test. In 2021, our trademark and patent in India was granted. At the same time, we have filed patents in US as well as Europe, which is published. We are awaiting the grant for the same. We started off with our journey from Department of Science and Technology with a grant called Nidhi Prayas. Currently, also we are on a government grant from Startup Karnataka, Elevate 2, and some of the media coverages that we recently had. We're very thankful for all these things, and yeah, that's all about Prayasta. I'll be happy to take any questions that anybody has.
Hello, Shilpi. It's a great presentation, and the topic is really interesting.
Thank you.
I have some questions concerning the price ratio between your product and plant that is in the market. Do you have a difference in the price wise?
So yes, we do have a lot of difference in terms of our personalized prosthesis and implant. If you just let me, can you give me a minute? I will tell you the exact pricing that we have really thought of, and I'll tell you. But let me tell you one thing, Ibrahim, that from what is available in the market to to our personalized implant, there isn't a huge difference in terms of pricing, but I would say around 625 USD is what we are targeting for our prosthesis, personalized ones. For implants, we would go for two products. One is the standard one, and one is the complete personalized. While I say standard, that doesn't mean that I will not incorporate the our USPs. But what we have also learned from the doctors is that sometimes on the table they decide how much breast has to be cut or how much deep they have to go to do the surgery, and hence we realize that the standard is also should be available with few of our USPs incorporated. So it would be around 1,000 euros. Personalized would be around 2,800 euros. Yes, as I mentioned, that personalized prosthesis would be 625. However, personalized prosthesis which are not 3D printed but are 3D mold casted is around $4,000, which are available in the market. By the way, I'm really sorry, I think I mentioned euro, whereas I'm talking about dollars. My apologies.
So if a patient come to you and asks for what's the better solution for me, what would you recommend?
So Ibrahim,
from
as
implant, wearable, yeah.
So so I cannot influence a patient firstly, because implant is something that the doctor has to influence the patient to go ahead with it, surgically fitted. Even though I want to sell my implant, I cannot do that. So the doctor has to give me the choice between the implant, which could be a personalized or standard, and a choice between prosthesis if the lady wants from me. Or else in terms of prosthesis, the lady can walk directly to me or put an order to me and I can go and scan her. For prosthesis, a doctor's intervention is not required, but for implant it is.
Yeah, I guess the wearable one could be really to many people, and it's a great idea. I'm astonished by this idea, as this is the first time I hear about it, honestly.
Thank you so much, Ibrahim. I would also like to praise you here. You're one of the very few men who have understood that why it is important for a woman to look normal. You know, many times because of cultural issue or some part of the geography which believes in something else. You know, even in India, I would say that men do not understand the need of looking normal and accepted. I have read so many papers, and I'm really astonished to read the psychology of a woman once she loses one part which is probably covered for her in many geographies for her entire life. But it's something which is very debatable, but yes, it is true that many of us do not understand the need.
Yeah, thank you very much, Shilpi Sen, for such a nice and presentable talk. It was really very astonishing to learn about your work, and seriously, our attendees love it. Seriously, Ibrahim is from the same thing. He's from the same line. He's working on cancer and other technologies in Lebanon, and he is our ambassador also for AdditiveMEA. So yeah, Ibrahim, it was such a pleasure to hear from you. Actually, the time is running. Yeah, that I would invite another speaker, but Miss Shilpi, you do stay. We will do a panel discussion in the end with you as well.
Sure.
Okay.
Sure.
Yes. Thank you very much.
Thank you.
Dr. Gosde, are you there? Dr. Gosde? Hello, Dr. Gosde, can you hear us? I think that she have put her mic off. Samia, are you there? How about your internet connection? Is this now okay?
Yes, it's fine. I can start. My presentation will be short. I will not take much from your time because I'm working in the educational field. So let me just share my screen. 1 second. Okay, can you see my screen?
Yes, we can see it now.
Okay. Okay, so my name is Samia. I'm currently working in Emirates School Establishment here in United Arab Emirates. And I'm a creative design and innovation instructor and professional development trainer for teachers who are originally coming from the engineering background. So most of the teachers who teach in the Emirates School Establishments come from, let's say, different engineering backgrounds like electronics, mechatronics, civil engineering, and also architecture. The topic of global women in 3D printing is very interesting, and it's one of the things that we are currently working in the Emirates School Establishment, which is part of Ministry of Education, where we try to, let's say, motivate young girls who are in high school and even those who are in their first year, freshman year in university, into, let's say, encapsulating the 3D printing technologies in their projects, let's say in their designs. So how can we do this, and how do we do it over here in the Emirates School Establishment? First of all, we start by teaching the students what does graphic means, what's the importance of graphics, and how it's important to understand the visual representation of an object. So as we can see that most of the students, once they want to explain their ideas, or let's say to highlight their ideas, they really sometimes get stuck on how to do that in their best way. So they start by creating some image, putting some videos, and even with that image, they slowly try to understand that image is it's only a 2D view. We need something that is more, let's say, realistic, something that more take us to the true idea and the true, let's say, the heart of the idea that they want us to understand. So so from there we tell them that image and visual representation of objects is important, but it's not enough. And that's why we need to understand what's the difference between technical graphics and CAD. And from there, we try to, let's say, train them on some of the technical graphics techniques. For example, how to draw isometric lines, how to draw perspective drawings. They learn all these types of techniques, which is the basic of engineering drawings. And they see that these types of drawings need somehow times And also it needs, let's say, it's not easy. It can be complicated, and some of the things you cannot, it's uncontrollable. So from there, we tell them that how about we go to the next level, and instead of just only relying on technical graphics, why don't we, let's say, use the true power of computer-aided design to represent our ideas, true ideas. And from there, we go to the graphical representation of objects using computer softwares, which is the 3D design. In the 3D design, and of course, we introduce them why do you need technical graphics. There are many reasons why do we usually, many reasons that we usually teach the students about why do you need technical graphics. One of the most important thing is to break the language barrier. Most of the students, their first language is Arabic, their second language is English. And some of them, they get scholarships to countries like that doesn't have where they don't speak Arabic or English. Sometimes they go to Japan, they go to France. From there, especially those who want to specialize in engineering, they want a way of, let's say, representing their ideas during the time that they are learning this language. So one of the things that we tell our students that why it's important to understand the technical graphics and also elevate these technical graphics by using CAD designs is to break the language barrier. And furthermore, we tell them that maybe your ideas can be, let's say, a point of interest for someone who wants to invest in this idea. And therefore, the best way to convince investors is that you provide them with a clear, let's say, clear view of what you are trying to approach. And from there, we start with the computer-aided design, and we usually focus on Autodesk, let's say, softwares, and mostly we focus on the immersive school establishments of Fusion 360 software. So students learn the basics of Fusion 360. They try to, let's say, slowly try to understand what are the types of views in the software. So for example, over here, this is where we tell them that this is the true, let's say, the true power of using computer-aided design, where you can control the finest detail of your design so that you can be able to explain your idea, demonstrate your idea to the audience that you have very clearly. And also you can be creative. So let's say, even if you have one idea that was in your head, once you go through the engineering design process, which is where we teach them the 7-stage engineering design process. And once you reach to the final design, you will see that whatever you thought about is not going to be the same, because you have a software that allows you to do things that was unexpectable. So we teach them, let's say, the true power of the 3D design software, which is Fusion 360. What are the types of views, and how can you, for example, control your design with, say, the smallest details in your design using different views, the different tools. And the main three things that we teach in the 3D design is how, first of all, to create a 2D sketch, try to create and try to let's say, change this 2D sketch into 3D model. And of course, from this 3D model, how can you bring it to reality by going through the 3D printing process. Also, we tell them that once you are using computer-aided design, they actually don't tell them, they slowly discover that it's not always that we start with a 2D sketch. We can sometimes start with a 3D design, a 3D object. And this is the power of using a computer-aided software, where you start with a 3D object and you modify this 3D object using different tools like chamfering, shelling this object, filling this object, revolving around this object. And slowly you can have something that is more unique and more innovative than the one that was in your original plan. So this is just a small explanation about this. Then we go to the types of 3D printers that we commonly use in the schools and in the vocational institutes over here in UAE. And we tell them what are the 3 different types of these 3D printers, the different techniques of these 3D printers. We start by the stereolithography and how does it work? And of course, there are videos and some lesson plans for that. Then we go to the selective laser sintering, and finally we end up with the fuse deposition modeling technique, which is another types of 3D printers. Students over there try to understand the different types between these 3D printers, the application that can be used by each one of them, and how can they, let's say, how can they, which printer will be suited for their design. Sometimes the 3D printers that we have in, let's say, in the schools or the vocational institutes that we work with might not be sufficient. So we go to, let's say, for example, the Fab Lab, where they have more, let's say, advanced, and they have more variety of 3D printers. Of course, once we start doing that, we try to teach the students how can they use the keyboards in a proper way, how can they use the mouse in a proper way. We go through does the students go and navigate through the Fusion 360 software, till how to create a plan, till they go to their final design project. Now, we've done a lot of projects with the students. Over here, I'm going to share with you a link with a gallery that we did with one of the schools, where we combined all their designs in one by using one software called eMaze, and we created a gallery of all their 3D designs that they had done during the term. And then some of these designs we even went to print them in the schools, during the schools. Of course, the printing was done, and also the circuits inside these designs was done. Now, one of these projects, which is one of the interesting projects for these students, is the autonomous vehicle, where they understand, they try to design different shapes, different models of these autonomous vehicles. And mostly we were focusing on a concept that on an event that is happening currently in UAE, which is the Expo 2020, and what are the types of autonomous vehicles that can be used in Expo 2020, and from there, how can we replicate it in our designs, and how can we even try to solve some of the issues that currently exist in the autonomous vehicles that is available currently in Expo, and how you as a student can provide a better solution so that it can be used in let's say future events, especially that in UAE autonomous vehicles market is growing, and by let's say the year 2030, let's say 1/3 of the cars in Dubai by itself will be fully autonomous. So from there we came up with this idea. I will share with you the link for that. Just 1 second. Okay, till the time I share with you the link, I would like to see if you have any questions about what we are doing. Of course, I gave a very, very brief idea about what we do in immersive school establishment. The projects that we have done, there were many various projects that was done and delivered to students. So is there any questions from your side?
Hello, Samia.
Okay, yes.
Thank you for the presentation.
Thank you, Brahim.
I want to ask you, at what age the students start about 3D printing technology?
Okay, originally in 2016, the idea of the 3D printers to be in the immersive schools, let's say, or the government schools, has started in 2016 from grade 11 to grade 12. sorry, from grade 10, 11, and 12. So the focus was on high school. But slowly they realized that this is not enough, and students should learn about 3D design and 3D printing technologies from an earlier age. So they introduced a new subject called design and technology, which is basically taught for cycle 2, let's say, students, starting from grade 5, 6, and 7. Where the students use small, simple softwares like Maker Empire, and let's say 123D design, and some of this and another software in the Tinkercad, where they design some small, let's say, 3D objects, and they print them. And from there, let's say Ministry of Education had worked very hard to deploy different types of 3D printers that suits those different ages. Of course, considering the safety measurements and also, let's say, the age group. So you will find that the types of 3D printers in high school are slightly different from the 3D printers that is deployed in Cycle 2 schools. And now there is a new plan that Emerald School Establishment is trying to do, is to create the largest 3D printing competition in UAE, and it will be launched by I would say April. By April, slowly now the students have they are starting the registration. They didn't finalize the ideas, but it will be launched by April. Anyway, there was an announcement that had been circulated to schools that you need to get ready. We need to see the plans for each and every. Each and every school, what have they done and how they use this 3D printing, because they want to see the competency level coming from this technology. So over here, I will share with you right now the gallery that we did. And as you can see, we tried to combine, this is one school called Kulthum Secondary School for girls, and it's here located in Al Ain area in Abu Dhabi. And first we started, we gave the students, let's say, predefined designs that we had already done by ourselves. So the website is slowly, a little bit slow, but as you can see, there will be 2 videos over here explaining what is the autonomous vehicle designs and an introduction, a small introduction. Then we gave another design. Once again. Okay. I prefer that I share the link with you, and you can, let's say, you can navigate the website.
You can share the link in the chat as well. Anyhow, do your university offer the careers for the students as well? Like if they wanted to make the career in the 3D print?
Definitely. In fact, they are now focusing on the aerospace engineers. And one of the universities, which is the UAE University, we recently visited, they have, let's say, a dedicated lab where students, let's say, they study the aerodynamics and they study, for example, the air modelings of airplanes. And then they not only design, usually the students usually stopped in UAE University specifically, they usually stopped on the design, let's say, stage, but now they had deployed, like they had designed like one of the biggest, I would say, labs that has different various 3D printers. And this lab is in collaboration with Google. And from this lab, now students can also print their air models, let's say the models of the that they study. So for example, if they are studying a certain concepts, the aerospace engineering curriculum, they directly go to the design, and they directly go to the lab and try to print and see whether this modeling is really working. And that is now, it's only possible because of the 3D printing technology. I would say, let's say 6 years before, something like that was not over here. It wasn't even like the country is already trying to deploy these technology, but to reach to this stage, I would say that this is a huge advancement.
Yes. Yes, there are many big questions which we wanted to have with you. I do apologize as the time is running by. I can confirm the next speaker, but do stay with us. There are many questions which we can discuss on regarding the careers on the students as well as the medical 3D printing and other benefits. And you can also share in the end about if your students have been making any designs and the prototypes that they have made. So we can
Okay,
conclude it
I'll
at the
share
end.
right now of the
Okay,
galleries
okay.
that we did with one school,
Yes.
and also some of the designs that we did, so whether it was robotic arms, let's say smart speaker designs, smart LED lamps, and so on. But currently, I will just share this. Sorry, because we have a little problem with the network.
No
Yes.
issue, no issue. You can share the link. You can share the link as well, and we can conclude it on. Okay, but do stay with us. We will invite you for a panel as well. Okay, and yes. Thank you very much. Thank you very much. Dr. Gosde, are you there?
Yes, I'm here. Can you hear me?
Hi. Yes, we can hear you.
Perfect. Thank you so much, Piyush. Thank you for giving me this opportunity to speak with you today.
So, how about the sessions? Did you like any sessions you are being staying with us for the long? How about the sessions you have managed in the AdditiveMEA?
Yes.
Like on the speaker.
Let me share my screen first of all, but I cannot share my screen, I believe. Oh, okay, it's here. Okay, can you see my screen very well? Are you able to see my screen?
Yes, we can.
Okay, perfect. Okay, thank you so much. Today, my name is Gözde Altunpedük. I'm from Turkey actually, but I live in US for 8 years. I have a PhD degree in additive manufacturing, and I'm a material scientist. After 10 years in manufacturing and materials science, I decided to continue my career on the software side, and then right now I'm working at Stylo company. As an agenda, I'd like to start with the introduction part. I'd like to speak with you about project management principles and approaches for additive manufacturing, because I believe it's a very important topic. We are all doing projects, but it's important to touch on the approaches for additive manufacturing. And I will continue my talk framework for additive manufacturing application and software solutions, tips and tricks. So project management as a general idea is the experienced combination of all skills, knowledge, and experience to achieve specific projects objectives according to the project's acceptance criteria within agreed parameters. So in additive manufacturing, we have two different approaches: waterfall approach and agile approach. So as a new technology, agile approach is very popular. Agile is known as from software solutions, but it's also adaptable to additive manufacturing, because additive manufacturing in the process we start with design, and then in the very fast-paced environment we are creating and building our products. So in the waterfall, if we compare it, we have to decide our requirements from the beginning of the project, and then in a long term, in 6 months or 3 years, we continue our project. So in Agile, we have under Agile umbrella, we have Scrum and then Kanban. This is the most famous one. What's Scrum? Scrum is a framework for project management that emphasizes teamwork, accountability, and iterative progress towards a well-defined goal. So Agile is best approach for additive manufacturing because our requirements are being decided at the beginning of the project, and then it's open to change. Each time we can change the project without any delay. For the Scrum application, you can see development, commercial software, and then newly additive manufacturing. This is actually software development lifecycle. From my perspective, it's additive manufacturing development lifecycle, because at the beginning of the project, we define our requirements. we list all of them, and then we do design, we do create and then design. After that, it could be electron beam melting or any other 3D printing or metal manufacturing methods. We do manufacturing. And then from the customer's perspective, if we are working in a high level, in a high scale environment, we have to present them our prototype or product. So we do implementation, we do verification and validation from the customer. And after that, after we present our product, we do stage. So agile is an incremental, so it's adaptable to additive manufacturing, and waterfall is a linear approach. So in agile, we separate a project into sprints, compared to waterfall divides a project into phases. In Scrum, we have some meetings like some ceremonies, I can tell. In Scrum, we have self-organizing teams, product progresses in a sprint series, in a series of, we call it sprints, and requirements are captured as items in a list of product backlog. So in additive manufacturing, if we implemented Scrum characteristic to additive manufacturing, we have to organize our teams collaboratively. And then we have to divide our projects into small increments, into small sprints. Scrum framework, in Scrum framework, we have some roles: product owner, developers, and Scrum master. So roles is gonna be changing in the additive manufacturing, but artifacts like product backlog, you can see sprint backlog and product increment will be same. So we have 5 events in the Scrum: sprint, sprint planning, daily Scrum, sprint review, sprint perspective. So it's very important because if we divide in the sprint, we can control the project step by step. For example, if we do sprints in each 2 weeks, we can check our results. In each 2 weeks, we do sprint planning meeting at the beginning of the projects. We define how many days or hours take. For example, for design, it takes creation 3 days, or 2 days, 4 days. And then after that, machine preparation for electron beam melting. Let's say that powder supply, we are waiting from the inventory. So in the sprint, if we reflect it, so our projects will go over smoothly. And the other main thing is daily Scrum is very important. Compared to waterfall, we have Scrum meetings. In additive manufacturing, we do actually. Every day we do Scrum meeting with our small organization. We check our daily list, what's done best, what we have to do in a day. So we can also check our results daily basis, and then defects. Defects is another part. It's very hard to control defects in additive manufacturing. So with daily Scrum, we eliminate our failures if we implement agile to our projects. And product backlog structure, it's very important because in the beginning of the project, it's like a hamburger. You can think is additive manufacturing layer by layer process. At the beginning, we define technical requirements, and then we have business requirements from the customer side. But what's their expectation? If it's an aircraft product or if it's an implants, we will have different requirements and different parameters. For example, if we're gonna produce build Ti-6 alloy, we will have different machine parameters for laser beam melting, electron beam melting. So those are covered in the business requirements. And then performance. In the performance, we can define it like machine performance, and then software performance. Research is the main thing in additive manufacturing. If you are especially developing materials, I develop nickel tire alloy and then other stainless steel Ti-6. So if you are developing new materials, you have to do research, you have to check other journals. And then defects. After production, you have to check defects with microscopy for metal additive manufacturing I'm speaking, and then you have to do your mechanical testing. and support structures. Support is like you can think like post-processing, so it's here. Scrum framework for additive manufacturing. We have testing, printing in daily basis. We have design and processing, and Scrum team will be working on all of the stage. So we will check with the customer at the end of each sprint, like 3 weeks. We will show our results, and after 3 weeks, we will show our prototype, and then we will get regular feedback from the customer, and then we can change our process very easily. So this is another example. For example, let's structure creation and then step-by-step process in the product backlog. Software solution. In my company, we have some software solution. So in the agile process, you can do with Excel spreadsheet, you can implement your processes. Another high solution is software solution, because in the software, you can check your schedule. In the project management, we have golden triangle: scope, schedule, cost. You have to balance 3 of them. Scope is very important. That's why we are referring requirements. And then in the software solutions, you can add schedule management, inventory management, reporting. You can control everything on daily tasks. You can put estimate for each task, and then step by step, you can change the status to aware everyone. And then you can also, based on the projects, you can define your risk. It's very important. So tips and tricks for the project management and agile is very important since we are 15 minutes over. So from my experiences, I'd like to talk about tips and tricks for women in additive manufacturing. It's not easy job. You have to be patient, of course, because it's step-by-step process. It's very fast process, but you have to wait sometimes. Soft skills are very important. Soft skills, I mean, for example, problem solving. It's very important. In the each stage, you solve the problems. And then communication is very important. 95% success is based on the communication. If you communicate very well with your team members, so your success rate will increase. And hard skills, and creativity from the soft skills is very important for additive manufacturing. It's key factor. You have to create, you have to design from on your mind. You can build anything based on your creativity. And hard skills are computer skills. And then, for example, SolidWorks or the other software skills, or material science, metallurgy, or testing. Those are the hard skills you can gain. Balance golden triangle: scope, schedule, cost is the best one, because at the end of the day, if you are working for a company, you are responsible for your customers, and then you have to send product backlog according to their rules. So you have to balance golden triangle: scope, schedule, and cost. End of my talk. We are encouraging additive manufacturers, young additive manufacturers, especially. Actually, last year, this group, I'm the owner and founder of this group, a co-founder of this group, Young Additive Manufacturing. Young Additive Manufacturing. The goal is to support new people on additive manufacturing side, because it's very hard to find network opportunities, job opportunities, even materials for their personal development. In this group, we would like to compile all of them. We'd like to share resources between each other. So feel free to join this group. We will be growing, I believe. So I think it will be very helpful for all of us. You can reach me at any time if you have any questions. I will be happy to answer.
Yes, thank you very much, Dr. Bose. It was such a nice presentation. We were really delightful and pleased to see how the work has been going on and how you're working on these sectors. If someone want to ask any question from Dr. Gosde, they can ask. Otherwise, we will move for a panel. I think there is not any question. Hello.
Yes.
Hi, Ankita. How are you?
I'm good. I'm good.
Okay,
So
okay,
can we
thank you.
start the panel discussion?
Yes, yes, yes. Dr. Gosde, are you there?
Yes, I'm here.
And Ms. Shilpi?
Yes, I'm here.
Okay, okay. That's very great. Samya, if you also can join us, you can join us. I've seen you here. Samya?
Yes, I'm also here.
Yeah. So we will do a small panel discussion. We will discuss on it. I would like to welcome Ms. Ankita Avasti. She is the professor at IILM and she is helping a lot as the AdditiveMEA in increasing the awareness to the 3D printing itself. So she will be the moderating and we will continue. So over to you, Ankita.
Thank you, Piyush. I'm delighted to be here and I'm listening each and every talk and I'm so inspired. As in, I am teacher by profession, but I'm designer by heart. That is my sole thing which I would like to share with you guys. And I'm a little bit working in pre-operative templating in orthopedics and actually trying to set up myself in merging with the artificial intelligence and augmented reality and virtual reality. So let's start the panel discussion. So I just want to ask, this is an open discussion and whosoever wants to answer the question, they can. So my first question is how you guys are drifted towards the additive manufacturing? What kind of motive behind it? Means which thing propelled you towards the additive manufacturing to just have start your journey with additive manufacturing?
Shall I go first?
Yeah, please.
Okay. So thank you, Ankita, for the question. So basically, to be very honestly telling you, I am somebody who doesn't have a fancy degree in science. I'm the only person in this panel probably who's from the humanities background. But what drove me or what attracted me towards additive manufacturing is that the the quality by which you can make a product personalized. The way things move now in today's world, where personalization is very important in terms of medicine, in terms of organs, in terms of anything that is coming up latest now, is something that really made me very get attracted to this. And for the very first time in my life, I had seen a 3D printer in 2017 at Vikas's, the other co-founder that I have, at his house. He had made a printer, which is a desktop printer from scratch. And I saw it working. It really made me, I was looking at it like a child. So which made me realize that, how fancy is the world, because I am a communication specialist. I was always in the larger corporates working, or for the government that I was working for. So I never had a chance to look at something, advancement of technology with that close eyes. So which made me realize that, as I mentioned earlier, that personalization can be done, and hence what Prayasta, my startup, is doing is to make personalized breast implants and prostheses for mastectomy survivors. Yeah, that's my take on what attracted me towards additive manufacturing. Thank you.
Okay. Dr. Godse?
Yes, I can. Yeah, it was 2013, I remember. Especially patient-specific implants took my attention from an article. I noticed that it's the feature of the technology. So my interest started with electron beam melting. Unfortunately, in that years I was in Turkey working as research assistant, and there were no additive manufacturing machine in our country. And then I decided to continue my career on that side. And then with my passion, I moved to US. North Carolina, NC State University was the first university for housing electron beam melting machine. I went there, I've been accepted there. I learned all the technology, I used their machine. So I was very happy after that time. So my journey started with additive manufacturing since 8 years.
Oh, nice. Then the same question is for Ms. Samia.
Okay, I would say my journey started with 3D printing when I started leading a project here over UAE. It was the first STEM-based project. It was collaboration between government organization called Al-Bayt Al-Mutawahid and Google. So usually Google have every year, they have a sort of funding and they wanted to start promoting the, let's say, STEM culture and focusing on the 3D printing and 3D design, of course. And from there, specifically, they were focusing on the Northern Emirates, including the rural area of the Northern Emirates, where they don't have the same access, just like Dubai and Abu Dhabi. And from there, we actually had different types of tools for the additive manufacturing, starting with the doodlers, the 3D doodlers, where students learns about the 3D, let's say, modeling, the difference between modeling and the difference between design itself. And of course, finally to the 3D printing. And from there, I really understood the meaning of equipping, let's say, young generations with such a powerful tool. I mean, one of the examples that I showed students at that moment is about one guy. He had used 3D printing to develop his own, let's say, retainers for his teeth. And he used to print that for, let's say, an interval, for 12 months interval. And he fixed his own teeth just by using the 3D printing and the 3D design concept. So imagine what the limitations can be unleashed using this, especially if you start, let's say, with the young generation from a very young age. And this is what I believe makes it interesting. And this is what actually motivates me more and more to learn about this technology and to be even better in that. Another thing is that my brother, he's in Australia currently. He recently started a 3D printing company to build 3D houses, especially for houses that have been demolished by the floods, the recent floods. And I can see his business is going very well. And they are a group of 3. They finished their PhD from Monash University, and they wanted to go there to experiment with this technology. And now they are getting, let's say, very large orders. So I believe even my next step is not going just to be in the education, to be a person who just instruct and direct the students to use the technology, but I'm also focused, I'm also trying to see how can me myself, let's say, expand in this technology and see, let's say, an interesting application. Right now, I've seen very interesting application by Miss Shilope, right? Sorry.
Yes.
Yes. And it's really, I would say, one of the, let's say, most innovative application. It's something that is not only, let's say, something like a normal application, or let's say an accessory. No, this is something that can change a person's life. So imagine if you can expand from that. So yeah, this is.
Absolutely, absolutely. And my second question is, what message would you like to share with women entrepreneurs and job seekers in this domain? So, Dr. Godse.
Yes.
Yeah.
So what skills? I couldn't get the question. I'm sorry.
Actually, what kind of message would you like to share with the women entrepreneurs or the young girls who want to start their journey in additive manufacturing, and any job seekers for this domain?
Yes, thank you for the question. Start from somewhere. It's very important. If they have 3D printers at their schools, they can start with small projects, step by step. For example, I have a 3D printer in my home, and then my 3 years old daughter, sometimes we are printing small objects just for fun. So maybe for the parents, they can do same thing for encourage women in 3D printing. And then in the YouTube, we have so many resources. They can start and then they can watch their video with university professionals. They can get in touch. They can visit their labs. I'm sure they will be very happy to share the informations with each other. So never give up is very important because we will have challenges on all the stages of additive manufacturing. So, and if you have passion, I'm sure they will be very successful. From the job side, job market is changing for additive manufacturing, especially in US. But if they can catch from somewhere, from some topic, if they can start with internship for the young generation woman, it will be good career path for them. Thank you.
Thank you, Dr. Gose. Now, Ms. Shilpi, please enlighten us.
That's a pretty big word that you just used, enlightened. So I would really agree with Dr. Kotse here. For me, if I have to really say, it started off with getting very fascinated with something which was very beyond my, you know, normal work routine. However, nowadays, what I see that the trend has really changed in terms of job seekers. And though there are still a tendency of doing your engineering and then doing an MBA and then getting into a bank, at least in India. The mindset that I see now, if somebody is coming from a mechanical engineering background or a biochemical or a biomaterial engineering or something to do with similar background, they now want to explore few possibilities that are available in the market, wherein they can go ahead and use their expertise and knowledge in a field which is though new but coming up big time. And I'm sure with all these things, with so much of change that's happening, this field is going to see an exponential growth. And in terms of job seekers, I also would like to bring your attention here that people whom we hired as interns, mostly we have taken them as a regular employee, because you don't want to lose an asset and you don't want to really waste your training on a person who really comes and then leaves. So it becomes imperative also for a company to identify few talents within the workforce that they have and encourage them to come up with new ideas. Thank you.
Absolutely, absolutely. Miss Samia, sorry,
Yes.
Samia.
I actually do have, yes, please, Samia, continue then.
I would say that 3D printing, or let's say 3D design, it's a way or a tool to discover the undiscovered, not only between the young. So this is what I would like to advise the young generations and the young seekers, that just don't use it as a tool to just to print your ideas. Let's say it can really take you to a new, let's say, whole directions that has not been there for the last decade. Previously, as Shelby said, that engineering student, I'm coming from an engineering background. I have also masters in control engineering, where let's say we focus on application. At least we use 3D printing as part of the application. But what I would say is, I would advise any person who is, let's say, wants to join this field, that don't start from that point. You can start from, how can 3D printing open new gates for me? Not how can 3D printing just be used as a tool to implement my project. And I would say this will not happen in one day. It will happen over a period of time. So that's why we start from, let's say, from school. It starts from school, and slowly, by the time those young generations and those young women reach to university, they will really understand. At least they will have let's say, a bottom idea of what is the reality of 3D printing, because many people just observe it as a tool to use it to implement some project. But no, it's not like that. It's something that is more than that. And we are really getting to learn more and more about it every day.
Very true, very true. So now I would like to invite Mr. Piyush.
Yes, yes. I actually have 3 questions, and then we can conclude it. First, my first question is for Ms. Shilpi. Imagine I am a woman. I'm a very beautiful woman with a good figure, but suddenly I got a breast cancer, and I have seen your website as well. Like you are doing a good job. So how would you recommend me, or what would you say to me if I come to you as a beautiful woman as a patient? And my second question is for Dr. Gosde. Like, what is meant to be an advocate for additive manufacturing? She is a very good advocate. I have seen the advocate in laws as well as other things. So what could be it meant for the advocate in additive manufacturing itself? And my third question is for all of us. Imagine I am a student. I have just completed my mechanical engineering. I am also good in some doing designs. I can do graphics as well. And now I wanted to make a career in 3D printing. So from where should I start and where should I move on? These 3 are my questions. That's it.
Should I go first?
Yes, sir.
Okay, thank you, Piyush, for that question. However, I'm assuming you are a handsome man. And now that I have to assume that you are a beautiful lady too, so let me have that liberty of assuming all the possible thing under the sky right now. So like your question is that you are a beautiful woman and you have a great figure and you have lost your breast because of breast cancer or mastectomy. I, as a manufacturer, would not be able to influence the decision whether you would go for an implant or a prosthesis, because this is a decision that is either taken in consultation with your doctor for an implant and as a with your family as for a prosthesis. So if you remember, I had mentioned that if you walk to me for prosthesis, I will be more than happy to give you a prosthesis because it is not surgically fitted inside your body. However, implant is. So even if I manufacture the implant, I will not be able to sell directly to the end user who's a breast cancer survivor because she needs a surgeon to surgically fit it. And an implant obviously cannot be opened in an uncontrolled environment or a normal room. It has to be controlled. The box has to be opened in an operation theater like condition, or a clean room facility is what we call it. That's how I, as a manufacturer, cannot influence any beautiful lady who has a very beautiful figure, or even if you're not beautiful outside, but you're a beautiful person inside, even then I cannot influence you in any whichever way because it totally depends on your perspective and your doctor.
Sure. Thank you very much.
That answers your question.
Yeah, definitely. And thank you for that. Dr. Gosde, my same question is for you. What is meant for additive manufacturing advocate?
Yes, additive manufacturing advocate means to put additive manufacturing into your life and then to improve your skill set towards additive manufacturing, set your goals for additive manufacturing, spend some time is very important. You have to spend some time. You have to always search. You have to follow new articles, and also for advocate network is very important. You have to improve your network from all over the world. LinkedIn is a very good platform. So you have to share your knowledge with other people. And to be in the process is very important. You can voluntarily start somewhere in university or in the job. that's the small steps, but big scale for additive manufacturing. It will be big steps for career journey.
Yes, yes. Thank you very much. Thank you
You're
very
welcome.
much.
Thank you.
Yes, yes. And my last question, and we will conclude after this. I imagine if I'm a student, I'm a mechanical, I have a good engineering background, as well as I'm good in designing. I can draw whatever I can want with my imagination as well on the paper and on the design as well. I have seen that 3D printing 3D printing is full of making the things from your imagination, and I want to make a career in it. So what would be the first step I should have to do? Anyone can answer this. Samya as well, Shilpi Sen or Dr. Gosde.
You can actually apply for an internship with a company who's already working in an additive manufacturing space. And as a design engineer or an intern, or as a graphic intern designer or whatever. So I think the first step would be to identify your caliber and to then identify a particular additive manufacturing company that really interests you, and then probably as a student who's recently passed out should apply as an intern and explore a few possibilities within the company at that time. That would be my take. Others can differ.
So I could go as an intern and join the company and then do the work as well and learnings.
Yes, if you're good at it, I wouldn't like to lose you.
How about the school level? What if we imagine after 5 years, as like after 11th we took science, arts and maths, and after this, how about the school level? If the 3D printing could be generated there, how about the school level opportunities, like for the PhD candidates and other people to make a career in there? Should they join some university or should they work under someone or like that?
Again, it totally depends on your interest. Piyush, Dr. Kotse is with us. She's done her PhD and is an advocate in this additive manufacturing space. I'm sure that she would have better knowledge and better expertise to answer this question. So I'll leave it to her.
Hello. Yes, I think Dr. Gosde having some network issue. Dr. Gosde, are you there?
Yes, I had. I'm sorry, I switched my phone.
Oh,
My
no,
battery was over. Yeah, I couldn't hear the last part. Thank you so much, Piyush, for having us today.
Yes. We can conclude this today. Thank you everyone for joining us. Thank you, Ms. Shilpi. Thank you, Dr. Gosde. Thank you,
You're
Atta.
welcome.
Thank you, Ankita. Thank you, Saladin. Thank you, every other participants. Thank you, Ibrahim, as well. We will upload this video on the YouTube as well. So if any participants want to see us on YouTube or Instagram, we will upload the sessions at there as well. And you can easily see us. And we are also having our AdditiveMEA 2022 International Conference on 3D Printing and Additive Manufacturing Technology, which is taking place on April 13th and 14th in Dubai. So it would be a great pleasure to extend my invitation to all of you, and we will see the benefits and the opportunities for everyone. Thank you everyone for joining us. It was a good pleasure. Thank you everyone again.
Thank you so much.
Thank you.
Thank you so much.